Hello everyone, welcome back to our Arduino course. In this video, I'm going to show you what are DC motors and how to control the direction of them clockwise and counterclockwise, and use PWM signals to control the speed of DC motors. Also, I will show you two types of motor drivers. The first one is L298 motor driver, and the second one is 8871 motor driver. After that, I will use both of these motor drivers in my project to control the speed and the direction of DC motor with potentiometer for setting the speed and two push buttons for changing the direction of the DC motor. At the end, I will show you how I wrote the whole code for this project. Let's start. So what is DC motor? DC motor is an electric device that can transform electrical energy into mechanical energy. Electrical energy, the power which is coming from the battery, DC power, and the mechanical energy is the spinning of the motor. The operating voltage of this motor is from 5 volt to 12 volt. The motors which I'm using in my video, the voltage is from 5 volt to 12 volts. But for sure there are different types of motors. They have different operating voltage. Some of them they have 25 volts, 36 volts. Actually, it depends on the motor. So you have to check the data sheet, then you can see which voltage is required for this motor. DC motor has two terminals, positive and negative. If you connect the positive terminal of the motor to the positive of the battery and the negative of the motor to the negative of the battery, the motor will start spinning clockwise. If you change the polarity, so if you connect the negative of the motor to the positive of the battery and the positive of the motor to the negative of the battery, the motor will start spinning in the other direction, which is counterclockwise. As you can see here in this demo, we have power source 9 volt. I connected the positive to the positive, negative to the negative, the motor spinning clockwise. And here we changed the polarity, negative to positive and positive to negative, and the motor starts spinning in the other direction, counterclockwise. If you have a motor in your circuit and you want to change the direction of this motor, for sure you will not come and change the wiring. This is not practical at all. So we have a circuit called H-bridge, or there are some modules, they have this circuit, we call them motor drivers. So if you have a motor, you should have a motor driver to control the direction of this motor. Also, we can control the speed of the motor through these drivers. I will talk about it later. So what is H-bridge? H-bridge, it's an electronic circuit that can drive the motor in both directions, clockwise and counterclockwise. It has 4 transistors, MOSFET transistors, with a reverse diode. These diodes for protecting the MOSFETs from the power which is coming from the motor. As we know, the motor has coils inside it. It has coils, and these coils store energy. So when we turn off, for example, the motor, this energy will discharge through this diodes, and it will this energy will not affect on the transistors. So that's why we have these diodes. If you don't have these diodes, this energy, maybe it will burn the MOSFETs. That's why we have this reverse diodes to protect the transistors. So let's see how this circuit or H bridge works. If we apply 5 volt on the transistors Q1 and Q4, and we apply 0 volt on Q2 and Q3, how the current will go through this circuit? Let's see. The current will come from the battery or from the main source. It will go through Q1 because, as I said, we applied 5 volt on this transistor. It means the circuit is closed here. So it will go through Q1 to the motor. Then it will go through Q4 to the GND. As I said, on Q4 also I applied 5 volt. So it means closed here. The circuit is closed here. So how the terminals of this motor are connected? This terminal is connected to the positive of the battery, and the other terminal is connected to GND or to the negative of the battery, and the motor will start spinning clockwise. If we apply 0 volt on Q1 and Q4 and we apply 5 volt on the transistors Q2 and Q3, let's see how the current will go. So this is the V bat, it means V battery, or the positive of the battery. So the current will come from the positive of the battery, will go through Q3 because I said I will apply 5 volt on Q3. It means the circuit is closed. It will go through Q3 to the first terminal of the motor, or it will go through the motor to Q2, and here the circuit is closed. I applied 5 volt, and it will go to GND, from Q2 to GND. So this terminal is connected to negative, and the other terminal is connected to positive, and the motor will start spinning in the other direction, counterclockwise. As you can see here, I changed the polarity of the motor. Positive, negative, here negative, positive. So it will rotate or spin in this circuit counterclockwise, and here in the first one it will spin counterclockwise. And in this way, or using this H bridge, we can control the direction of the motor. Now, how can we control the speed of the motor? We can control the speed of the motor using PWM signal, which is a signal that can change the amount of power delivered to the motor through the duty cycle. So it's a signal that can change the power which we apply on the motor, or it can change the voltage that we apply on the motor. By changing the voltage which we apply on the motor, we can control the speed. For example, if you apply 5 volt on the motor will spin slowly. And if you apply 12 volt on the motor, it will spin faster. So the PWM, it will do that. This is how it works. So it has duty cycle, and this duty cycle, it will change the amount of power that we apply on the motor. So what is duty cycle? A duty cycle, it refers to the ratio of time that the signal is in a high state over the total time it takes to complete one cycle. We express about it as a percentage. So as you can see here, duty cycle equal T on divided by T multiplied by 100%. 100%, as I said, we express about it as a percentage. Here is a cycle. This red as you can see here in red, this is one cycle. So T equal T on plus T off. This is one cycle, T on plus T off. And this is the second one, and so on. So T, as we know what is T, and T on, as I said, this is T on. If we increase T on, then the speed of the motor will be faster. If we decrease T on, then the speed will be slower. Okay, so duty cycle is responsible about changing the speed of the motor. Or in another word, we can say the duty cycle is responsible about changing the power that we apply on the DC motor. Let's have an example. For example, if we have a duty cycle 10%, then the voltage and we apply a voltage on the motor 12 volt. So we apply a power or voltage on the motor 12 volt, and the duty cycle is 10%. What is the total what is the total voltage that applied on the motor? So V equal 12 volt, which is the power of the battery, multiplied by 0.1. It's 10%. 0.1. It's equal 1.2 volt. We apply on the motor 1.2 volt. Then the motor, it's almost off. It will not spin. 1.2, it's not enough to spin the motor. So we can say the motor is off. Let's increase the duty cycle. Let's say our duty cycle is 50%. Then the voltage equal 12 volt. It's the power of the battery multiplied by 0.5. And it's equal 6 volt. The voltage that we apply on the motor is 6 volt. 6 volt, it means the motor is spinning in half speed. We can say in half speed. The total voltage is 12, so here we applied 6 volts, so the motor will rotate or spin in a half speed. Let's change the duty cycle to 90%. Then the voltage that we apply on the motor equal to the voltage of the battery multiplied by 0.9, and it's equal 10.8. 10.88, it means the motor will spin faster, and so on. So if you increase the duty cycle, then the voltage will be increased, and also the speed will be faster. Where can we apply these PWM signals? PWM signals, it's applied on the base of the transistors. We apply these PWM signals on the base of the transistors. Instead of applying 5 volt to control the direction, we can apply the PWM signals on these bases or on the bases of the transistors. Then we can control the speed and the direction at the same time. Let's talk about the motor drivers. I will start with L298 motor driver. This motor driver has 2 H-bridge circuits for controlling the motors. The power supply is from 5 volt to 35 volt DC, and the maximum current is 2 amps. Here is the motor driver. It has 2 boards. This is the first one, and this is the second one. Out 1, out 2, this port for connecting the first motor. Out 3, out 4, where we can connect the second motor. And by the way, you can connect more than a motor on one board. For example, on out 1 and out 2, you can connect 2 motors on this port, but you have to make sure you don't exceed 2 amps. If you exceeded this current, maybe your H-bridge or your L298 will burn. So make sure your motors will not take power more than 2 amps if you want to connect more than a motor on the same board. Even if you connect one motor on the same board and this motor will take more than 2 amps, your H bridge will burn. So make sure from the amps of your motor. Here on this port is for powering the module. The first one, it's written next to a 12 volt. Here where we can connect the positive of our battery. As I said, the powering is from 5 volt to 35 volts. And this power, for example, here it's mentioned 12 volt. If you apply on this port 12 volt, then the voltage which you apply in your motors is 12 volt. If you apply, for example, 9 volt on this port, then the power which you apply in your motors is 9 volt. The second pin or the second port is GND. It's the negative of the battery. Here where we can connect the negative of our battery. The third one, it's written next to it 5 volt. Here we can take power because this L298, it has voltage regulator, 5 volt voltage regulator, and we can take power 5 volt from this board. Make sure you cannot give power on this pin. You can take power, which is 5 volt from this port, and here on 12 and GND you can give the power from the battery, not on 5 volt. 5 volt only to take power from this board, not to give power. Maybe you can give power from 5 volt to Arduino. You can power your Arduino from this board. But make sure don't connect your battery on this board. And here we have 6 pins. Enable A, N1, N2, N3, N4, and NB. Enable A and enable B. Okay, enable A, it's for control. It's here where we can apply our PWM signal. N1 and N2 for controlling the transistors. For controlling the transistors and the direction of our motor. So the first 3 pins, enable A, N1 and N2 for this motor, which is out 1 and out 2, and N3, N4, enable B. These pins are for out 3 and out 4. We can control this motor through these 3 pins. So as I said, enable A, N1 and N2 for controlling the motor which is connected to this port, and enable N3 and N4 and enable V for controlling the motor which is connected on this port, out 3 and out 4. Enable A for controlling for the PWM signals, and enable B for PWM signals for the second motor. Enable A for the first motor, enable B for the second motor, which is connected to out 3 and out 4. As I said, N1, N2 for controlling the transistor for the first motor, N3 and N4 for controlling the second motor, which is connected to out 3 and out 4. Here N1, if you apply 5 volt, T1 and T4 closed, and the motor, and if we apply 0 volt on N2, these 2 transistors T2 and T3 are open, and the motor will spin clockwise. If we change, for example, on N1 5 volt and N1 0 volt and N2 5 volt, then T1 and T4 are open, T2, T3 are closed, and the motor will start spinning counterclockwise. This is how it works, this motor driver. So let's see the second one. Here is the second motor driver, which is 8871. This motor driver, it's more simple. It has one H bridge circuit for controlling the motor. The power supply is from 6.5 volt to 45 volt DC motor, and the maximum current is 3.6 amps. As I said, it has 1H bridge. It's very simple. It has here 4 pins, N1, N2, VM. It's the voltage where you can apply the positive of your battery. GND, where you can apply the negative of your battery. Same, this port, it says power. Also, you can connect your battery on this port. You can connect the positive of your battery on the positive and the negative of your battery on the negative. Here I said 12 volt because my DC motor is 12 volts. That's why I'm using 12 volts. M1 and M2, on this port you can connect your motor, the terminals of your motor. N1 and N2 for controlling the direction of the motor and the speed. As you can see here, we don't have PWM pin as the previous one, where we can apply our PWM signal. Here in this module, you can apply your PWM signals through N1 or N2. For example, if I apply on N1 PWM signal and I give 0 volt on N2, then I can control the speed and the direction of the motor at the same time. The motor will spin clockwise and I can control the speed at the same time from the pin N1. If I apply PWM signals on N2 and 0 volt on N1, then the motor will start spinning counterclockwise and I can control the speed of the motor at the same time through N2. Here is our first scheme for the first motor driver, which is L298. Here is our circuit. Let me explain it. We have Arduino Uno, potentiometer. I connected the middle pin of the potentiometer to A0 and the other 2 pins, one to GND and the other one to 5 volt. Why I need this potentiometer? I will use this potentiometer for controlling the duty cycle, for setting the duty cycle and control the speed. So I'm using this potentiometer for setting the duty cycle. I will change the duty cycle, and at the same time, when you change the duty cycle, you can control the speed of your motor. So we can say this potentiometer is for controlling the speed of the motor. And we have here 2 push buttons. I connected them, one to pin number 2 and the other one to pin number 3. And as you can see here, I connected them to GND. The other 2 pins, I connected them to GND. And here I'm using pull-up resistor. So I didn't use external resistor. I'm using pull-up resistor, which is inside Arduino Uno. Why I'm using these 2 push buttons? Just to control the direction of the motor. If I press, for example, this push button, the motor will spin clockwise. If I press the second one, the motor will spin counterclockwise. And here, as I told you, I'm using one motor. I didn't use the other port. I connected my motor to out 1 and out 2. This is DC motor, which I'm using. And here my battery, I'm using battery 11.1 volt. I connected the positive of my battery to the pin, which is saying here 12 volt. I connected the positive to this port, and the GND or the negative of the battery to GND port. As I told you, 5 volt, you can take power from this pin. Don't give power to this pin, you can take power. You can, for example, take power from here and power your Arduino instead of powering Arduino from USB. And don't forget to connect GND to your Arduino. You have to connect this wire. I connected the negative of the battery to the GND, and make sure to connect GND from the module to your Arduino. You have to do that. And another one note, I have to tell you about it. In this L298 we have jumpers on enable A and on enable B. If you want to use the PWM and control the speed of the motor, and here I'm using the PWM signals, you have to remove the jumpers from this pin. I'm using enable A, that's why I removed the jumper from this pin, which is connected between these two. If you remove the jumper from these two pins, which are connected to enable A, then you are able to control and send PWM signals on this pin. Don't forget, there are two jumpers, one on enable B and the other one on enable A. If you want to control and use PWM signals, you have to remove them. So now let's go to our code. Here is our code. First line, I defined integer variable, I called it pot from potentiometer with initial value 0, because I want to save the coming data from the potentiometer in this variable. Then I defined N1 as pin number 5 in Arduino and N2 as pin number 4 in Arduino. N1 and N2, the control pin in the motor driver. And I defined enable A as pin number 6 in Arduino, and you have to make sure you connect enable A to PWM pin. And pin number 6 in Arduino, it's PWM pin. How I knew that? Let me show you. Pin number 6, as you can see next to it, there is this sign. This sign, it means this pin is PWM pin. As you can see here, number 3, it has this sign. Number 5, 9, 10, 11. All of these pins, which they have next to them this sign, they are PWM pins. Then I defined button 1 as pin number 2 in Arduino and the button 2 as pin number 3 in Arduino. And here I defined integer variable, I called it motor state with initial value 5. This is for coding purposes. I will show you later why I defined this variable. In void setup, bin mode, I defined N1, N2, enable A as outputs, and button 1, button 2 as inputs. As you can see here, input pull-up, I enabled the pull-up resistor, which is inside the Arduino. I don't want to use external resistor, that's why I used the pull-up resistor, which is inside Arduino Uno. In void loop, first I'm reading the data, which is coming from the potentiometer. Bot equal analog read. Analog read, it means I'm reading analog data, which is coming from the potentiometer on the pin A0. The pins A0 till A5, they are analog pins in Arduino. So I'm reading the data which is coming from the potentiometer using this instruction, which is analog read, and here between these two brackets the pin number. Here I defined a new variable, I called it speed, and I'm using the map function just to scale. I want to tell you one thing. Analog read, the data which is coming from the potentiometer, it's between, or it's from 0 till 1.23. This is the range of the data which is coming from the potentiometer. So if you rotate your potentiometer, you will get these values from 0 till 1023. This is the minimum value of the range and this is the maximum value. And map function, I'm using map function just to scale this range to another range, which is from 0 to 255. So I'm using map function, it takes these parameters.
Here pot, it means the variable which you want to scale it, or to scale the range of its data. Here you can put the range, the first range that you want to scale, and here these two parameters you can put the second range that you want to get. So as I told you, the range of pot from 0 to 1023, and I want to scale this range to a new range, which is 0 255. Why from 0 to 255? Because I want because the duty cycle in Arduino, we can express about it in Arduino in this range from 0 to 255. So we can express about the duty cycle in this range from 0 to 255. So I want when I change, or when I rotate the potentiometer, to get this range, not from 0 to 1203, not from 0 to 1023. I want to get this range. So now if I rotate the potentiometer, I will get this range, not the previous one, and it will be saved in this variable, which is speed. Now here I said if digital read button 1, if I pressed button 1 and button 2 is not pressed, give the motor state, this variable, the value 1. Give it this value, which is 1. Else if the button 1 not pressed and I pressed the button number 2, give the motor state this variable, the value 0. So if I press the first button, I want to give the motor state this value, which is 1, and if I press the second button, I want to give the motor state the value 0. Now I will control the speed and the direction of the motor. I said if motor state equal 1, it means if I pressed the button 1, analog write, enable A, speed, it takes two parameters. Enable A, which is the pin, PWM pin number 6, and the speed, it's the duty cycle. I said the duty cycle in Arduino from 0 to 255. So speed, as I said, I changed the range from 1023 to the new range, which is from 0 to 255. So the speed will take the new range. The value of the speed is between from 0 to 255. It depends on the position of the potentiometer. So if you rotate the potentiometer, the values will be from 0 to 255. So here speed from 0 to 255, and as I said, it's analog write, not digital. Analog writes, I use this instruction just when I want to give PWM signals on PWM pins, which is here pin number 6. And as I said, the speed, it means the duty cycle from 0 to 255, depends on the position of my potentiometer. And I said digital write N1 high, because I want to give 5 volts for the transistors T1 and T4. And then I said digital write N2 low. I want to give the transistors T3 and T2 low, just
to control the direction of the motor. So the motor here will start spinning forward clockwise. It will spin clockwise. Else if motor state equal 0. So what does that mean? It means if I pressed button number 2. So I said analog right, enable A speed. I want to control the speed. As I said, the speed is duty cycle from 0 to 255. And here what I changed, I said digital right, N1 low. And N2, I said digital right, N2 high. Just I changed the direction of the motor. So here the motor will spin in the other direction, or reverse, or counterclockwise. Else analog right enable A 0, it means, and I said digital right N1 low, N2 low, it means stop the motor. So this is our code, and let's see the practical test. Here is our circuit. I'm using lithium polymer battery, 11.1 volt, 35C, 4 ampere. It's 3 cells. And this is the L298 motor driver. I connected, here is a brushed motor. I connected the brushed motor to the port out 2. And here we have 3 ports. The first one is connected to the positive of the battery. The second one, it has 2 wires. It's connected to 2 wires. One is the negative of the battery, and the second one is going to the GND of Arduino. The third port is 5 volt. I'm not using it. And here is the control pins NA, N1 and N2. Enable A, it's PWM pin. I have to connect this enable A to PWM pin in Arduino. I connected to pin number 6 in Arduino Uno. And and N1 and N2, I connected N1 to pin number 5 in Arduino and N2 to pin number 4. And don't forget to remove the jumper. I remove the jumper which is connected on enable A. As you can see here, I don't know if you can see. Yeah, I removed the jumper to be able to use this PWM. You can remove it like that. Let me try. This is from this jumper. I removed it from enable B, but you have to do it on enable A. As you can see now you have 2 pins. These 2 pins, I removed the jumper from this 2 pins from enable B. You have to do same on enable A. I'm not using now enable B. You can let this jumper here, but you have to remove it from enable A to be able to control the speed of the motor. And here we have 2 push buttons for controlling the direction of the motor, clockwise and counterclockwise. One is connected to pin number 3 and the second one is connected to pin number 2 in Arduino. And here we have potentiometer for controlling the speed of the motor, and the middle pin is connected to A1. As you can see here, I connected to pin A0, I connected the middle pin of the potentiometer to A0. I want to control the speed of the motor. Yeah, this is our circuit, and let's test it now. Let's try now. I already connected the battery, and just let's start with the potentiometer. And it's not working. Yeah. Let me set it to 0. Yeah, I have first to click on the bottom. Now, as you can hear the sound from the motor. Increase the speed more. Now it's started. As you can see now, it's rotating. Now the motor is spinning. Can decrease the speed. Now let me increase it. Now it's spinning fast. We decrease it. Now it's rotating clockwise. Let me change the direction. Now it's rotating counterclockwise. Clockwise, counterclockwise, and we can control the speed from the potentiometer. And if you want to stop the motor, just decrease the speed, and that's it. And this is our second scheme. Here we are using the second motor driver, which is 8871. It's same the previous one. Here I connected the potentiometer to A0 and two buttons for controlling the direction, potentiometer for controlling the speed. Here I connected the battery, as I told you. I connected the negative of the battery to GND and the positive of my battery to VM, which is powering the motor. And I connected N1 to pin number 9. As you can see here, there is this signal next to it. It means PWM. And N2 to pin number 10. As I told you also, it's PWM pin. Here we don't have the third pin as the previous module. Here we will send the PWM signals through N1 and N2. That's why I connected N1 and N2 to PWM pins. And here I connected my motor to the motor board. Let's go to the code. Here is our circuit, and this is the driver 8871. As I said, it has 4 pins, N1, N2 for controlling the motor, VM, GND, VM the positive of the battery, GND is ground. And we have 2 boards. Here this port, which is written next to it, power. Here where I connected my battery, it has positive and negative. I connected the positive to the positive of the battery and negative to the negative of the battery. And the next port is, which is written next to it, motor. Here I connected my motor. This motor. I connected this motor to this port. We have 2 push buttons for controlling the direction of the motor, clockwise and counterclockwise, and potentiometer for controlling the speed of the motor. And our battery is 11.1 volt. We connected, as I said, the battery to the power, to this port, and this is the voltage which we apply on our motor. So let's test now our circuit. Let's test it. Okay. So here is the driver. So let me hold the motor. Okay, I restart. Rotating the potentiometer. As you can see now, it started. We control the direction now. See? Now it's rotating in the opposite side, in the opposite direction. Let me stop the motor. Yeah. Okay, thank you for watching. See you in the next video. Bye for now.